Dear students, in my previous video I have taught you what is Bayesian learning, what is Bayes theorem, and how to apply it over the concept learning problems, and how to find the optimal hypothesis in the concept learning problem using the brute force algorithm. In this video you are going to learn what is map hypothesis and what is a consistent learner. So it's a very small concept and an easy concept to understand. So what is a map hypothesis? So map hypothesis is a hypothesis. A map hypothesis is a consistent hypothesis. It's a consistent hypothesis. So every hypothesis consistent, every hypothesis in D which is consistent is a map hypothesis. So whatever hypothesis you have, and if it is consistent, then the value of the posterior probability will be 1 by modulus of ESHD, or it will be 0 otherwise. So this is the value for a consistent hypothesis. So every hypothesis which is consistent is a max hypothesis. Next, coming to a learning algorithm, a learning algorithm is said to be a consistent learner. So for example, take the case of students. Some students learn during the time of the exam, and however they get mark by hurting or whatever they do, but when they want to go and face interview, they will not be able to recall. There will be lot of errors in the concept because they would have mugged up or by hearted without understanding the concept. The consistent learner is one who outputs, or a consistent learner, when he goes for an interview, the probability of him getting selected will be high because there will be no error. So here the same concept applies here. The learning algorithm is a consistent algorithm if its output, if the output of the hypothesis has 0. The output has 0 errors. So a consistent learner is one whose hypothesis has 0 error over the training example. So with these assumptions, every consistent learner is expected to output a map hypothesis. Map is maximum or posterior hypothesis. So every consistent learner should output a map hypothesis provided there is a probability distribution over H, which is defined over H, that is P of Hi is equal to P of H, that is probability. Prior probability of I instance is equal to prior probability of J instance, and also you have noise free training data. So noise free training data will give you P of D by H will be equal to 1 if both D and H are consistent. If both D and H are consistent. So we are going to apply the same to the finders algorithm. So what is the objective of finders algorithm? You will be having a hypothesis space, and in this hypothesis space you are going to output a maximally specific consistent hypothesis. So this is the aim of your hypothesis finders algorithm, that is you will start from specific to general, and finally you will find the more specific hypothesis. So this finders algorithm, it will output a map hypothesis based upon the probability distribution of P of H and P of D by H. So how will you find the probability distribution with the prior knowledge? So, and now the question arises, is there any probability distributions available for these two values, P of H and P of D by H? Yes, there. So what we assume is, yes, there is a probability distribution, capital H. So this probability distribution is defined over P of H, such that we assign that P of H1 is greater than or equal to P of H2. So from this, what we infer is H1 is more specific. H1 is more specific. So by with the help of noise-free data and also and also with the assumption that your hypothesis is a consistent learner, that is, it outputs only a maximum hypothesis with these assumptions, and we have a probability distribution. So when we have a probability distribution, what we have as output is a maximally specific hypothesis. So what happens here is this learning algorithm, it does not manipulate any probabilities. It just identify the probability distributions of P of H and how it is distributed. Now you would have learned about the normal distribution, the Gaussian distribution, the exponential distribution. So you will see how P of H is distributed and P of D of H, D by H is distributed over the prior values. So by identifying the probability distributions of P of H and P of D by H, we can we can expect the algorithm to output the optimal value. That is, the map hypothesis is the optimal value. So what happens here is what we expect or what we infer from this map hypothesis and consistent learner is it's a noise-free data, and the other assumption what we have considered here, and the other assumption is that it is a consistent learner. So these two, consistent learner and the second one, I'm sorry, noise-free data. These two assumptions have been considered, and we are not going to manipulate the probabilities explicitly. Just find the best optimal hypothesis by finding the by applying your by applying the probability distributions of P of H and P of D over H. This is your this is all about your map hypothesis and consistent learner. In our next video, we'll learn what is maximum likelihood and least square errors, how to apply maximum likelihood for predicting probabilities, and how to apply it in neural network, and minimum description length principle. Thank you.